In this section, we're going to talk about solving quadratic inequalities. Now, we're going to solve these algebraically, but it's worth taking a minute just to understand visually what has happened. We've solved linear inequalities and absolute value inequalities, and we've seen that the solution is a set. So it's an inequality of something greater than, less than, whatever. And so a quadratic inequality in one variable needs to be written in one of the following forms. Notice that all of these forms, the quadratic is being compared to 0. The reason why we want to compare to 0 is because if we think of this graphically, okay, so if I want to figure out where the graph of f of x is greater than 0, and again, this graph is f of x, okay, greater than 0, if f of x is my y values, the y values that are greater than 0 are going to be all of the places where the graph is above the x-axis. And since we're talking about x values, that would be the x values between -1 and 5. Again, we're looking for above the x-axis. That's how we would figure out where it's greater than 0. And so we could say f of x is greater than 0 for x values that is -1 is the lowest, less than x, less than 5. Now, one thing that I do want to point out to you is that if you know how to use interval notation, you can certainly use it. The way that we would write this using interval notation is we would say -1 to 5. Now, this looks like an ordered pair, and it could be if we were talking about ordered pairs, but since we're talking about inequalities, we would use that. An interval is a really great way to write these kind of between inequalities. And so with intervals, if you use parentheses, that would be for less than or greater than. Parentheses mean you don't include the endpoints. Or you can use square brackets, which would be for less than or equal to, or greater than or equal to. And it could be a mix, okay? So for example, if I said that -1 is less than x but less than or equal to 2, then I would put a parentheses on the -1 and I would put a square bracket on the 2 to show that it is included. We also, if I have something like, let's say if it's just a greater than, I don't have an in between. If I just said something like x is greater than 4 or x is less than or equal to 2. Think about what a number line would look like, okay? The left arrow represents towards -infinity and the right arrow represents towards +infinity. So that's what we're going to use to show either the upper bound or the lower bound. So greater than 4 would mean an open circle at 4, and we would shade everything here. So open circle at 4 would mean parentheses on 4, but then we go forever towards the arrow, so that means our upper bound is +infinity. That's how you could write that using an interval. Less than would be the opposite direction. Less than or equal to 2, and we would go this way. We always write from left to right, so that means we're starting this time at -infinity, and we go up to 2 with a bracket because it is included. Notice that I only put parentheses on infinities because infinity is not a number. We can't be equal to infinity, so we would do it that way. You are welcome to use either inequality or interval notation, but I know that some of you have seen interval notation before, so you can certainly use it if that is the case. Okay, I'm going to shrink this down just a tiny bit. So where is the graph less than 0 is the next question. Well, less than 0 is going to be anywhere that it is below the x-axis, and that happens in 2 places. And again, we can assume that this graph keeps going because it doesn't tell us that it stops. Dots would be there if it stops. So there's going to be 2 places where we are below the x-axis. I need to write a little smaller here. We are below the x-axis. Again, if we're using intervals, we would say starting from -infinity and going up to -1. And the other one would be, I need to move this down, positive 5, and going on forever to infinity. As inequalities, this would be x is less than negative 1 or x is greater than 5. Either of those would be fine. And then where is it equal to 0? Those are going to be our x-intercepts. So that happens at exactly negative 1 and exactly positive 5. So that's going to be at x equals negative 1 or positive 5. That's where the graph is equal to 0. Okay? So this is why comparing to 0 is really important. On the x-axis is where f of x is equal to 0. Above the x-axis is where f of x is greater than 0. And below the x-axis is where f of x is less than 0. So that's kind of what we're looking at. So graphically, we can solve inequalities by looking at the picture, okay? And so depending on the inequality, if it's equal to or not, we will either include the x-intercepts if it's less than or equal to, greater than or equal to, or not if it's just less than or greater than, okay? So here's some graphs. Number 1 says, where is the graph of f of x greater than or equal to 0? Well, equal to 0 is at 1 and 3, and greater than is going to be all of this section right here. So the answer would be including positive 1, and then all the way up to 3, and 3 is included. As an inequality, we would say 1 less than or equal to x, less than or equal to 3. Again, we're comparing f of x values, but the solutions are x values. We're finding the x's that make that true, okay? Number 2, where is f of x less than 0? Well, here's our boundary points, the x-intercepts, but we don't want to include those because we only want less than this time, but we do want everything below. So this time it will be from negative 2 to 1. We're using parentheses because we don't include the x-intercepts, but we do include everything in between. Or you can say negative 2 less than x, negative 1. And again, each of these is an either or. You don't need to write both the interval and the inequality, just one is fine. Now 3 is kind of tricky. It wants to know where is x greater than 0, which means we do not want to include where x is equal to 0. So we do not include 4, but we do include everything to the left because it's positive on this side, and everything to the right because it's positive on this side as well. So the answer would be negative infinity to 4 and 4 to infinity, or we would say x is less than 4 and x is greater than 4. Either way that you want to write that is just fine. So that's what we're looking for graphically. But if we had to graph these every time, that would be difficult. And if the x-intercepts are not nice whole numbers like that, it can become even trickier. So we are going to look at a couple of examples here of how we would do this algebraically. So what we're going to do is find the x-intercepts because that's where the graph touches the x-axis. So if it's going to change from above to below the x-axis, it'll happen at the x-intercepts. Then we're going to choose some test values. The question is the section of the graph positive or is the section of the graph negative? So like on this graph here, if we just think about our x-axis, we have negative 2 and positive 1. Those are our x-intercepts. The graph is positive on this side. It's negative in between, and it's positive over here. So we're going to use a number line like that to test the sections of the graph to see if they're positive or negative. And then we're going to choose the right one based on the inequality that we need. This is why it must be compared to 0. Okay, so number 4, the first thing that we need to do is make sure that it is compared to 0, which it is. We have less than 0. And less than 0 means that we are looking for the negative sections of the graph, okay? So first thing we need to do is find the x-intercepts. And to find the x-intercepts, that's always going to be where the quadratic is equal to 0. So we want to solve this equation first. Then we'll use a number line to figure out our inequalities. So I cannot use square roots here. So then my next question is it factorable? And it is. I get -4 and +1, and even better, this is an a equals 1 shortcut. So we can go straight to our factors. X minus 4, x plus 1 equals 0. Remember, the way we solve this is we want to solve the two equations where does each factor equal 0. So the solutions we get are +4 and -1. These are the x-intercepts. Okay, so now, just like I kind of showed you on the previous graph, we're going to set up a number line and do some testing. So we're going to test here, and we're going to test in the equation. So put your numbers in the right order. -1 comes first, and 4 is second. Now, we are not going to include the x-intercepts because it was just a less than, not an equal to. So I'm going to go ahead and put open circles here so I remember not to include those. And then we need to pick some test points. We can pick any test points we want. Just pick numbers that are small and easy to plug in. So I need something to the left of -1. The easiest option there is going to be -2. I need a number between -1 and 4, so I'm going to pick 0 anytime I can because it's an easy number to plug in. And then something bigger than 4, I'm going to choose 5. Now you can choose whatever you want. I could pick 97.734, but that's going to be really tricky for plugging in quickly in my head, okay? Now where we're going to plug these numbers in is we're going to test them right here. And you can test anywhere you want, but the factored form, if you have it, is always going to be the easiest place to test. So I just need to check if I plug in -2, and we can do this in our head. If I do -2 minus 4, I'm going to get a negative. And if I do -2 plus 1, I'm going to get a negative. If I multiply a negative times a negative, that means I get a positive. And that test value speaks for that whole section of the graph. So that whole section to the left of -1 is positive. Between -1 and 4, I'm going to plug in 0. If I plug in 0, I get a negative times 0 plus 1, which is a positive. Negative times a positive is negative. So that whole section of the graph is negative. And then lastly, if it's bigger than 4, if I plug in 5, I get a positive times a positive, which is positive. So I don't know exactly what that graph looks like, but I do know it's above the x-axis, then below, then above. So it's something like that. We want, remember, we want the negative section of the graph, because we wanted less than 0, what's highlighted up above. The correct solutions are going to be in this section of the graph. So we have open circle -1 all the way up to 4. There's the graph, so we can either write it using an interval, parentheses because of the open circle, up to 4, and that would be our solution set, or you could say -1 is less than, not equal to, just less than 4. Either of these solutions would be fine. Okay, so that's how that's going to work. That one was factorable, which was really nice. Number 5, I don't want to work all the way through because I don't want this video to get too long, but we would have to start on this one by subtracting 2. Because again, we need it to be compared to 0 to start. So for this one also, you would be looking for sections of the graph that are negative, okay? Now, let's look at one more that is not factorable because I want to show you one that's a little bit tricky. So let's look at number 6. Number 6 gives us an equation that is not factorable, unfortunately. But we can still go ahead. If I look at this, it's already compared to 0. That's what we want, okay? Now, this one, the inequality is less than 0, and again, but if it was greater than 0, we'd be looking for the positive sections of the graph. So it really doesn't matter. But for here, just like the first one we did, we're looking for negatives. Greater than 0 would mean we're looking for positives when we're looking at the sections. This, I cannot use square roots. It's also not factorable. Nothing multiplies to -3 and adds to -4. I also would not want to use completing the square on this one, which means we have to use the quadratic formula, okay? So quadratic formula, x equals the opposite of b, so +4, plus or minus the square root of -4 squared minus 4 times a, which is -3, times 1, which is c, all over 2 times a, which is -3. Okay, so we just need to crunch this down a little bit. I get 4 plus or minus the square root of 28 over 6. And now we need to simplify this. Now, a mistake that I've seen people making is trying to divide 4 and 28 and 6 by 2 right now. Again, that 28 is trapped inside the square root. We cannot touch it. But we can try to simplify the square root of 28. That's the square root of 4 times the square root of 7. So 2 root 7 is what we get. And now that I have 4 plus or minus 2 root 7 over 6, the 4 and the 2 and the 6 are all not inside the square roots, so we can divide all of those by 2. And so the best answer is 2 plus or minus 1 root 7 over 3. Those are our x-intercepts. Now, I don't know exactly where those numbers are on the number line, so I need to put this in my calculator to estimate. If I put it in my calculator with a plus, I get 0.2-ish, and if I put it in my calculator with a minus, I get -1.5. That'll be enough for us to understand where it goes on the number line. The answer we want is not rounded, so I want to leave it in the square root form, but I need that estimate to be able to know that on here, the one with a minus is going to be my first answer, and the one with a plus is going to be my second answer. Those values are also going to be helpful here. This is about -1.5. This is about 0.2. So I need a number that is less than -1.5. So I might test -2. Between -1.5 and 0.2, I could test 0, and then a number greater than 0.2, I could test 1, okay? The problem is we don't have a nice factored form to plug in, so we're gonna have to just plug it into this equation up here and see if it is positive or negative. And so you can just use your calculator to do that, but you will get that it is positive here, negative here, positive here. Okay, and since we want the values where the function is less than 0, then we want the negative section, and we do not want to include these numbers. So using interval notation, it would be 2 minus the square root of 3 over 3, or 7 over 3. Oops. And then it will include everything in between up to 2 plus the square root of 7 over 3. Or again, as an inequality, you would write your number less than x less than your number. Okay? So that's how you can do that. Number 7 is factorable again, and it factors to a perfect square, so that's a good one to use square roots. I would recommend that you look those up on the PDF so you can copy down the rest of those examples, but hopefully these two kind of walking you through will be enough to get you started for today.